Hi guys, this is the common factor. So this is where your hard part to start. So please pay close attention to what I do, what I say. If you have any questions, please come and see me for this. So this is a factoring. Factoring means that it's the opposite of what we've been doing. So remember when we had binomials by binomials, when we had the distributive properties, we actually expand the brackets by multiplying terms together and then add the like terms at the end. Now, then we're actually going backwards in terms of the process where when you have the expanded form, we're going back to the brackets, okay? Now, the common factors is the basics of those steps, so you really need to understand what to do and how that works. So, for the part 0, I just give you the simple ones. So in order for us to do the common factors, we need to be able to find the greatest common factor. Now from now on, I'm just going to call it GCF. So when you do that, you look one thing at a time, number by number, and x by x, y by y, z by z, okay? So take a look at the first one. It says 15, 25, and 55. If you take a look at it, the greatest common factor, meaning the largest number that divides all three numbers, is in this case 5, right? So our GCF is 5, so we're okay with that, right? Now then the next one we have, instead of numbers, we have x squared and y, xy, x cubed, and then y squared. So when you're doing and dealing with the variables, the way that we do is you take a look at the common variable and then take the lowest exponent. So in this case for the x, which I will actually highlight in green, so thankfully all three terms have x in it. So then what we have for the GCF as the first step is we will have the x. And if you take a look at the lowest exponent among the x's, then we have just x to the power of 1. So that will be part of our GCF. And then the next one, if we look at it, we have y, and y squared, which I just highlighted in yellow. And all three terms have the y, so that is common among them. Therefore, then we will put the y and look at the lowest exponent. Then hopefully you see that it is the y to the power of 1. So then our GCF will be x to the power of 1 times y to the power of 1, which is just xy, okay? And I'll just put it there. Now then, next one is the mixture of everything. So when you have number xyz, number xyz, number xyz, you look at the numbers first. So if you look at 6, 9, and 21, our GCF, or the biggest number that divides all three, is actually 3, right? And then if you look at the x's, which I will highlight in yellow, well, x is all appearing in all three terms. So then I put the x. Then the lowest exponent is this x over here, which is the power of 1. So that's good to go. Then the next one is then the y. So the first term has y, the second one has also y, the last one also has y. So we're just going to put y as well. And the lowest power is then the 1. So we're just going to put y to the power of 1. Now, last one is then z in all three terms. All three terms. So then in this case, we put z. I'll just use pink in this case. And the lowest exponent is then z to the power of 1. So then our greatest common factor will be 3xyz. Now then, one question is, what if one term doesn't have z? Or what if one term doesn't have x? What if one term doesn't have y? Then that variable won't be your common factor because it's not common on all three, right? So then that's that. So if we go back to, or not go back to, if we go to the part 1, we have monomial common factor. So I put the steps down for you. Okay, the first step is write the greatest common factor. So this is the first thing that we have to work on. So greatest common factor. And then open the bracket, write the result from dividing. Okay, dividing each term by GCF. And then you close the brackets. So let's actually practice this one. So first of all, we have to find the GCF. So from GCF, we have 12, 18, and positive 2. Those are the numbers. So find the common factor of those three, and we know that it will be 2. Now, here, if you look at it, we have b to the power of 4, b squared, but the last one does not have b, so b is not common on all three. Therefore, b is not part of our GCF, okay? So then our next step becomes then 2, which is the GCF. Open the bracket. Then you start dividing everything. So 12b to the power of 4 divided by 2 plus 18b squared divided by 2 plus 2 divided by 2, okay? So hopefully you notice that the 2 down here is because of this 2 in the front, which is the GCF in this case, okay? So then what happens is 2, then 6b to the power of 4, 9b squared, and then plus 1. Now again, you may ask me, why do we divide this? Well, again, remember, we're going back to the brackets. When we try our best to get out of the brackets, we multiply them. So since we're going backwards, then we go the backwards of the multiplication, which is division in this case, okay? So let's actually practice this one more time. So for b, our GCF, the first step ever. So then we have 2, 10, and 8. The common factor in this case is then 2. Then the next one is a. So let's see whether we have a in all terms, a and a. So since we have a, we can put a. Now then the lowest exponent is 1, so we don't have to put any more exponents anymore. Now the next one is then the x. Now I don't think we have any more x's after this, so it's not a common factor. Y as well, z as well. They are not appearing on all three terms, so it's not a GCF. So all you have to do is this. So 2a, so equals obviously, then 2ax, the first term, divided by 2a, plus 10ay divided by 2a, minus 8az divided by 2a. So hopefully you notice it that we're dividing everything by 2a, which happens to be what's in the front, which happens to be our greatest common factor, okay? So then this becomes 2a, and then obviously 2 divided by 2 is just 1, and then a divided by a is also 1, and then 1x. Now then 10 divided by 2 is 5, a divided by a is 1, that's gone, and then what's left over is y, minus 8 divided by 2 is 4, a divided by a is 1, so that's gone, and then the z is left over. So at the end, all I need to do is just get rid of that 1 in front of the x, and that is done. Okay, so hopefully you understand this. Hopefully you can actually do C and D on your own. Then we can actually do it. I'll just do it really quickly. So for this one, we have GCF. In this case is then, we can call it negative. Now I usually use negative when the highest term or highest exponent term, for example in this case, has negative, okay? Then I take the negative out as well, so then negative. So 3, 9, and 15, 3 is the GCF of all three numbers, and all the terms have the x, so then I will put the x. Well, the lowest power is 1, so then the GCF is negative 3x. Now then this equals then negative 3x, so then negative 3x squared divided by negative 3x minus 9x divided by negative 3x minus 15x cubed divided by negative 3x, and then close the brackets. Now then negative 3x is then, well, negative 3 divided by negative 3 is 1, x squared divided by x. Remember, we subtract the powers when you're dividing the same base. So then x to the power of 1, since 2 minus 1. Now, then hopefully you notice it is negative over here, and that gives me positive, and then 9 divided by 3 will be positive 3. X divided by x will be just 1, so that's gone. Same reason for here, that we have negative here, negative there, and that's going to give me negative, negative, so then that gives me positive. Now 15 divided by 3 then becomes 5. Then x to the power of 3 divided by x is x to the power of 3 minus 1, so it is 2. Right? Then I will reorder them from the greatest exponent, so 5x squared plus 1x plus 3, and then that's all. Now, then this one, same thing, GCF. So 25, 10, 30, the highest exponent is then b to the power of 4. So that has the largest degree, and that has negative. So I'll actually include the negative for the GCF. 25, 10, 30, 5 is the GCF of those three numbers. If you take a look at all three terms, the first term has b to the power of 4. Second one is b squared. Third one does not have b, so b is not the common factor anymore. So b is out of our common factor, so that's out. So we don't have to write b. If you put b here, then that is completely wrong since the last term does not have b. So then this one becomes negative 5, negative 25 b to the power of 4 divided by negative 5, minus 10b squared divided by negative 5, minus 30 divided by negative 5. And then negative 5 stays outside. Remember, negative 25 divided by negative 5 gives me positive 5. Well, there is no other b in the denominator, so b to the power of 4 on the numerator is intact. Now, negative, then negative here as well, right? So these two negatives gives me positive, and then 10 divided by 5 gives me 2. So then 2b squared. Same thing over there, negative, negative. So then it will be positive 6, and then that's it. So then everything is from the greatest power to the least power, and that's pretty much it. Okay, so that's the basics of the common factoring. And then part 2 is the binomial common factor. Basically the same thing. We just pretend or treat the binomial as a one term, okay, like the just a or b. So if you take a look at it, it's the same rule basically. Okay, if you take a look at it, we have y minus z, y minus z, same, right? So if you take a look at this, it seems the common factor, or these two terms share y minus z together. So we can say the GCF of these two is y minus z. I'll just put the brackets around it. Now this is where it becomes a little tricky, okay? Now remember that we put then y minus z, which is the GCF, and then we put 3x, not you, y minus z divided by y minus z minus 2 y minus z over y minus z, right? Now this looks very confusing, but if you bear with me, we can actually go this way. We have the y minus z same in both numerator and denominator. We can cancel them as if we had 3xy, actually let's actually put it 3x, I don't know, k divided by 3xk. We can cancel the k's out, right? So it works in the same way. It's just instead of having k, we have y minus z. So then same thing for the y minus z over here. So then this then becomes y minus z and then 3x minus 2. Now hopefully you notice this. Hopefully you notice that what we have with the first term in the question originally with the y minus z is the 3x and then minus 2. So hopefully you notice that the y minus z, which is the common factor of the two, stays in the front, whereas whatever that is left over seems they're just put together after all, right? So this is the shortcut of it. Now then, why did I show you what I highlight in this orange-ish color? Well, just to show you why the 3 minus x stays at the end, okay? So if the y part or the explanation part kind of confuses you, then try to remember that whatever that is left over from the common factor will stay together in the end or in the second brackets, okay? So let's take a look at this one. In this case, we have a plus b, right? We have two terms, one, and then we have two terms. In those two terms, we have a plus b as the common. So GCF in this case will be then a plus b. So this becomes then a plus b. Then whatever we have left over outside of a plus b, which is then 7 and minus 2x, will come in the second bracket in this way. Okay? So hopefully you can follow this. Okay, hopefully you can follow this. And the same thing for the C as well. So hopefully you actually try this on your own. Hopefully you pause the video and then try this one. Okay, but I'm just going to go. So for this one, if you look at it, 3m